Hello and welcome to class. Here we are, Math 30-1. Today we'll be getting into lesson 3.4, but first we need to look back at 3.3 because we didn't quite finish that lesson. So if you don't have your notes package out, you should pull that out. The two classes ended at slightly different points, and so there might be a little bit of overlap with what you looked at on Friday, but we'll get through that and then get on to some new stuff as we look at combining the transformations together. So on Friday we saw that this 2x inside the function resulted in a horizontal stretch by a factor of 1/2. So this point here that was previously at -4, 4 gets mapped to this point at -2, 4. So the x-coordinate, which was -4, gets divided by 2 and becomes a 2. The y-coordinate stays unchanged. So similarly for the next points, this point gets mapped to here. So the y-coordinate is the same, the x-coordinate is half as big. And the same idea for the rest of the points on that shape. In a similar way, we see that when we have the x replaced with 1/2 times x, then the result is a horizontal stretch by a factor of 2. So again, this x-coordinate that was at -4 gets doubled and gets mapped here to -8. Let's see if we can explain this in a different way. Suppose my x value in this function is a -8. What this function is going to do, because this half is here, is it's going to look and see, well, when my x value is half as big, so it's going to look here at -4, what's the y value for the function? Well, the y value is +4, but it's going to take this +4 and pull it over to the location where x is -8. So that's why the point that used to be here gets pulled out and it ends up being a horizontal stretch by a factor of 2 rather than a stretch by a factor of 1/2. So again, remember that whatever number is multiplied to the x, the opposite is what happens. So there's a horizontal stretch by a factor of 2. Here, in the previous one, there was a horizontal stretch by a factor of 1/2. So now as we look at this third function here, we see that the x is replaced with a -2/3 x. So first, let's look at that negative sign, and you will recognize that that negative sign means the x's are changing. So here, where I had an x value of -4, the sign will switch, and that point will get mapped here to +4. The result is that this original graph that we have here is reflected in the y-axis. So let's just move this reflected graph over onto the third grid here. And then we can perform the stretch. So we've taken care of the reflection. So the x is multiplied by 2/3. So the stretch factor is actually 3/2. So every x-coordinate will be 3/2 times as big, or 1.5 times. So here x is 4 times 3 divided by 2. We'll take it up here to where x is 6. Similarly, this point where x was 2 gets mapped here to a value of 3 now. And the final result is a graph that will look like this. And notice that the point that was on the x-axis is invariant, so that point doesn't move, it stays in the same point. So if you look down here to the summary that we filled in on Friday, we left the first part, and I think I'm going to leave that again, and we'll just focus on the second description here. When I have y equals a times f of bx, and that's a transformation of y equals f of x, we have a vertical stretch about the x-axis by a factor of a, and a horizontal stretch about the y-axis by a factor of 1/b. Moving on to example 5, we have the solid function that has been transformed into the dotted function. And so as we look at some of the key points, so as we look at this end here, horizontally, this point that was at 4 is now mapped here to an x value of 2, so it's half as big. And as we look at the other end, this point here that was at -6 gets mapped to here, which is an x value of -3. So we can see that there's been a horizontal stretch by a factor of a half. Now remember that this means that our b value will actually be the reciprocal of a half, so it'll be 2. Now as we look vertically, we can see that this point here that did have a y value of 2 now gets mapped up to here where we have a y value of 6. So that would be 3 times as big, and if I double check this point, 2 again, 3 times as big as 6. This point is 3 times as big would be 9, which is a little bit off the grid. So it looks like we have a vertical stretch by a factor of 3, which means that our a value is equal to 3. And so we can use these two parameters then to write our equation. Y will equal to 3 times f of 2x. So again, as we look back at our equation up here, we can see vertical stretch by a factor of 2, so our a value is 2, horizontal stretch by a factor of 1 over b, so we did the reciprocal of the half, I should say, to give us the 2. Now why don't you pause the video and look ahead to examples 6, 7, and 8 and work through those, see what you come up with for an answer, and then when you've finished, feel free to start the video and I'll put up solutions. So here we go. A vertical stretch is going to affect the range. And so if we have a factor of a half, then our range values will each be multiplied by a half, giving us a new range of -4, comma 1. And again, the parentheses will stay the same. We won't include the -4, but we do include the 1. Similarly, if we look at the horizontal stretch by a factor of 2 over 3, that will affect our domain. And so our new domain will need to take each value of the domain and multiply it by the reciprocal of that 2/3. So this will be times 3 over 2. And then the 12 will also be times 3 over 2. And again, the endpoints will stay the same. And so our range, I should say our domain, will end up being 9, 18. And again, the bounds are the same. We include the 9 at the left end and don't include the 18 at the right end. As we look ahead to question number 7, the 2 multiplied in front of the function, again, will affect the range, so that'll be a vertical stretch by a factor of 2. So we'll double our range values. So it'll now be from -16 up to +4. And as we look at our domain, since the x is divided by 3, what happens is the reciprocal of that, so our domain values are each multiplied by 3. So now our lower bound will be an 18, and our upper end will be a 36. Now question number 8 is kind of nice because mapping notation, which is what we have in question 8, tells us exactly what happens to each of the values. So here as I look at this, it's telling me that all of the x values get multiplied by a half. So I can just take my original domain and multiply each of those values by a half. So 6 times a half gives me 3, and the 12 times a half gives me 6, and there we have the domain. Similarly for the range, I can see that all my y values get multiplied by -3, so I have a reflection and I have a stretch. So for my range, I can look at my upper bound was a 2 times negative 3 gives me a negative 6. My lower bound was a negative 8 times negative 3 gives me a positive 24. So again, we always arrange them so that our smaller values on the left are larger values on the right, just like we would on a number line. Then keep in mind that this 2 was included, and so when we multiplied by negative 3, the 6 or the negative 6 is now included in the range. The negative 8 that we initially had as our left endpoint was not included, and so the 24 is not included in our new range. So there we have answers for these questions. Finished that lesson, took a little longer than I expected, but let's go on ahead and look at lesson 3.4. As we look at combining all the transformations together, I'd like to give you a little bit of time to work ahead here. Just keep in mind that if you think alphabetical order and we do reflections first, and then stretches, and then we do translations last, then you shouldn't have any problems. As we quickly look through these 4 graphing questions that we have, question number 1, all we have here is y's divided by something, which is a little bit different, but keep in mind we could rearrange this. And so this equation we could rewrite as y is equal to a half times f of x over 2. And then it makes it a little bit clearer for us to see what the a value and what the b value are. As we look ahead to question 2, you'll see that we still have that half in the denominator on the y side, which means the stretch is the same. We still have the 2 in the denominator inside the function under the x, and so the horizontal stretch is the same as in question 1 also. So the result you get from question 1, all you're going to do is a vertical translation and a horizontal translation. Looking down to question number 3, again think alphabetical order, so we'll do the reflection first, and once you've done the reflection, then you can do the stretches. As you look at question number 4, notice we'll have the same reflection and stretch vertically, and we have the same stretch horizontally because of that 3 times x, but keep in mind that as we looked at this on Friday, when we have any coefficient in front of the x that's not a 1, we need to factor that term out from both of these terms in there. Otherwise, we'll make a mistake in our horizontal translation. So, pause the video and work through these 4 graphs here, see what you come up with, and in a few minutes you can start this up again and compare your answers with mine. So here's what I have for questions 1 and 2. So again, this half here, or looking at the half underneath the y, that means we have a vertical stretch by a factor of a half, so this y value of 4 comes down to become a 2, which gives us the 2 value there. This y value here of negative 6 comes up and gives us a negative 3, which gives us the lower limit for the y value of that part of the graph. Similarly, x divided by 2 means it's horizontally stretched by a factor of 2. So this point where x was negative 6, doubled to give us negative 12. This point that was a positive 3 is doubled to a positive 6, so that's where this point comes from. And then this 6 doubled to become a positive 6 over there. And then if we just take this graph, and shift everything to the right by 3 units, and down by 1 unit. So again, remember, if that translation factor is grouped with the variable as it is with both the x and with the y, it does the opposite of what it looks like. And so here you probably recognize that this would be to the right because we have the x minus 3. If I have a y minus 1, y plus 1 I should say, then it will be translated down by 1 unit. Let's look at the next 2 questions. In question 3, if I start with this reflection, the negative sign that I have in front of the 2, it's in front of the function, not with the x's, which means it affects the y's. And so this y value of 0 is going to stay where it is for the reflection. this y value of 4, the sign will change and it'll get mapped down here to a negative 4. And this y value down here, where we have the negative 6, that will get mapped up here to a y value of positive 6. So a sketch of just the reflected graph will look like this. Then a vertical stretch by a factor of 2 will double all the y values. So the 0 stays a 0. This negative 4 would become a negative 8 down here. This positive 6 would become a positive 12 up there. And then we have our horizontal stretch. So remember, since the x is multiplied by 3, the b value is 3, so the stretch factor is actually 1/3. So this x-coordinate of negative 6, 1/3 will come here to a negative 2. Here, where x is negative 3, will be mapped to a negative 1. Here, where x is 3, it'll be mapped here to a positive 1, and the x of 6 to a positive 2. And so we get this red graph. And that is what this final transformation will look like for this function. As we look at question number 4, let's start by rewriting the equation. And as we rewrite it, we don't need to worry about the parameters that are outside the function. It's just the ones that are inside that we'll have to deal with. And so the minus 2 in the front, the plus 4 at the end, those we don't have to change at all. It's just that 3 inside the parentheses that we need to factor out from the x and from the negative 6, so I get an x minus 2. Now as I look at this, what I can see is that, again, I have a reflection that affects the y, so it's a reflection in the x-axis. I have a vertical stretch by a factor of 2, a horizontal stretch by a factor of 1/3, so that much gives me this red graph that I just drew in the previous question. So then I just need to take the red graph that I had there and do this horizontal translation, 2 to the right, and the vertical translation, 4 units up. Unfortunately, this takes our graph off the grid, but there we can get an idea of what it's going to look like. So if we break down our transformation into each of the parts and do a little bit at a time, then we can come up with this final graph. Let's move on to the next set of questions. So now what we have is we're given the equation for a function, and notice that question 5 starts on this page, it continues on to the back side, so the b and c refer back to this original function that we have here, which is f of x equals the square root of x. So as we look at being able to describe this transformation, again we want to do this in alphabetical order, so we'll look at reflections first, then stretches, then translations. So we start by looking for negative signs. Here we have a negative sign out in front of the square root, and so that'll be something that affects the y values for the function, which means we'll have a reflection in the x-axis. This negative sign is part of a translation, so we don't need to worry about that. There's no negative inside the square root with the x, so we don't have a reflection in the y-axis. Then as we look at stretches, we look for what's multiplied. So there's nothing multiplied out in front of the square root other than the negative, so we don't have a vertical stretch. But inside we have this 4 multiplied to the x, which means that we'll have a horizontal stretch by a factor of 1/4. And finally this minus 3 that's outside the function, so it's outside the square root, so it's not affecting the x's, it's affecting y's, so that'll be a vertical translation down by 3 units. And there we have a description of the transformations that have been applied to that function f of x equaling the square root of x. So I would like you to pause this video again and look ahead to the next few questions and see what you come up with. When you're ready, feel free to restart the video and compare your answers with mine. Notice for 5b that I've begun by rewriting the equation. Because I had my x value being subtracted, it had a coefficient of -1. So I needed to factor that negative out from both the x and from the 1. So I get negative parentheses x minus 1, close the parentheses, all underneath that square root sign. If we don't do that, then we're going to end up with translating it in the wrong direction. So here we have a reflection in the y-axis because of this negative sign right here. We have a stretch vertically about the x-axis because of that 3 that's out in front. And notice I used a little bit different wording here. For this course, we'll always be stretching about the x-axis and the y-axis, at least in this chapter. And so as long as we do the stretches first, before we do the translations, we'll always be doing it about the x and y-axis. Not a bad idea to get in the habit of stating it already, because after high school, you may be looking at stretches around other lines rather than just the x and y axes. And then finally we have the translation from the two terms that are added and subtracted. On to part C, and again we want to begin by pulling out a common factor that's underneath the square root. Now since we have this x over 2 here, we want to factor out a 1/2. Now at first glance it doesn't look like a half as a factor of 2, but if you think about it, how many halves are in 2? Well, if you have 2 whole pies, how many half pies do you have? You have 4 half pies. So inside the parentheses we need an x minus 4. So another way to think of it is when we're going to factor something out as a common factor, what we're doing is we're dividing both of these terms by that factor that we're taking out. So I'm dividing a half from here and a half from there. So x over 2 divided by a half just gives me this x. And the 2 divided by a half, remember when you divide by a fraction, you can multiply by the reciprocals, so it's the same as 2 times 2, which will give us this 4. So now that I have the equation rewritten in this form, I can start looking for reflections and stretches and translations. So negative sign out in front of the square root tells me it affects y's, which will mean that we have a reflection in the x-axis. The 3 out in front means that we will have a stretch vertically by a factor of 3, and the half in here that's multiplied to the parentheses means we'll have a horizontal stretch by a factor of 2. And finally, we have a translation, 4 to the right and 1 up. On to question number 6. Now question number 6 is kind of interesting because there's more than one correct way to describe this transformation. The simplest way to look at this equation would be to rewrite it as y equals 2 and then parentheses 1 over x plus 3. And if we look at it in this way, then we can see that this 1 over x is still inside the function, and all we have is the 2 multiplied in front, the 3 added on the end. So the only things that are happening vertically, or happening to the y values. There is no reflection for this function, but there is a stretch, and we could say it is stretched vertically by a factor of 2. And then it's translated vertically also up 3 units. Now I mentioned earlier that there is more than one way to describe this transformation, and that's because we could also rewrite this equation as y equals 1 over x divided by 2 plus 3. I'm going to let you think about how you can get that math to work, but if it was written in this way, then we could see that, or describe the graph as being stretched horizontally about the y-axis by a factor of 2, and the impact would be the same, so the two graphs would look identical. Finally, question number 7. I want to begin by rewriting this equation. So we have y equals 3, but then we have a negative 2 multiplied to the x, so I need to factor that negative 2 out in front. So then I'll have an x. When I factor negative 2 from the 4, I will get a minus 2. And that'll all be cubed, and then subtract 5 at the end. So if you're always able to rewrite an equation in this form, then we can easily see what we will have for reflections and stretches and translations. So negative sign here tells us about a reflection. Our x cubed function has been reflected in the y-axis. Then we have a vertical stretch by a factor of 3 and a horizontal stretch by a factor of 1/2. And finally we have a translation, 2 units to the right and 5 units down. And again, the order that you describe the translations, you could say 5 down first, 2 right second, that's okay. Similarly with the stretches, the order you describe the stretches, we can describe horizontally before vertically, those don't matter. As long as we describe translations last, doing reflections and stretches first, then there's some flexibility in the order we describe things. Okay, let's summarize all of this for the equation that we have at the bottom of the page. First of all, we know that our function will be reflected in the x-axis if our y values change, which means our a value is less than 0. We have a reflection in the y-axis if our x values have changed, so if our b value is less than 0. Our vertical stretch factor is the absolute value of a. So if a is negative, that's going to take care of the reflection. So we just look at the absolute value of a to figure out the stretch factor. Similarly, the horizontal stretch factor isn't b, but it'll be 1 over, and again we'll do the absolute value of b. That should be a 1 over absolute value of b. And then finally we have a vertical stretch factor of k units and a horizontal stretch factor of h units, as long as our equation is set up with a subtraction sign in front of the h and addition in front of the k. So there we have an equation that describes all of the types of transformations that we have looked at so far in this chapter. So you have the rest of this class time, assuming there is some time left, to work on these practice questions from the work text that are listed below. All right, I look forward to seeing you again tomorrow. Have a good day.